Good afternoon, everyone, and welcome. Thank you for joining us for today's LinkedIn Live discussion. My name is Suraj. I will be the moderator of today's session, which is AI in machine condition monitoring and predictive maintenance. So, for all our attendees on this call, over the next 45 minutes, we will be looking to explore how artificial intelligence is changing the way maritime organizations think about machinery health, maintenance planning, and operational reliability. The conversation today, we wanted to move beyond simple buzzwords such as AI and focus more on practical questions that people can actually use and take away which they can apply in their everyday working lives, such as how is AI actually being applied, what data is required, can engineers trust these outputs, and what challenges exist. And I think perhaps more importantly, how the organizations measure value. So I'm joined today by two highly experienced maritime professionals. They bring decades of engineering and operational expertise and excellence. From what I gather, collectively 60 years of experience. So I'd love to welcome Pratul and Yash. It's great to have you
Thank
both
you.
with us.
Thank you. Thank you.
Thank you.
So I think we'll get started. Yash, if you don't mind, let's start with you. From what I gather, you've worked across vessel operations, maritime education, digital maritime analytics, and you spent a considerable amount of time helping various organizations understand data and how to harness these data-driven insights to improve performance and reliability.
Yeah.
So before we dive into it, for all our attendees here, could you share a little bit about your journey, how you see AI and these digital technologies changing in the machinery maintenance landscape?
Firstly, good afternoon, everyone. I'm Yash Anand, and I work with an organization called Smart Ship Hub as a lead vessel performance analyst. Smart Ship Hub is a digital solutions provider to the maritime industry. And among its digital solutions, Smart Ship Hub provides data analytics, AI-driven solutions for vessel performance, and machinery condition monitoring. My background is that of a marine engineer. I went to sea about 40 years ago, and after having served for around 30 years, 10 years back, I retired from sea service. I also had a short stint in maritime education sector, and 4 years back, I joined Smart Ship Hub, where I combined my experience as chief engineer with data analytics, machine learning, and digital technologies to support basically vessel performance and machinery condition monitoring. While my core expertise is that of marine engineering rather than digital technologies, however, working close with Smart Ship Hub and interacting with ship owners, thought leaders of the industry, it has given me valuable insights into digital transformation taking place across the maritime industry, how artificial intelligence is rapidly becoming one of the key technologies driving this transformation. So along the way, I'll be sharing some of these insights and we'll chat about it.
All right, great. Thank you for that, Yash. So, I mean, before we jump into it, I think we'd like to set the context. If we were to begin at the highest level, whenever AI is discussed, there's a tendency for people to jump right into the technology aspect of things, right? But before we do that, I think it's important to understand why this conversation matters. So, what I'm trying to get at is why AI and why now? What has changed over the last 5 to 10 years, and what makes AI genuinely relevant for machinery maintenance today?
Yeah, that's a very pertinent question. Why AI and why now?
Yes. Yeah.
I'm sorry. Is someone trying to say something? Okay.
No, please go ahead.
All right. Yeah. So these are very questions which are asked very often. Let me take it in two parts. Why AI and then why now?
Yeah.
And if I were to rephrase this question, I would ask, what makes AI such a powerful tool for machinery condition monitoring and maintenance and other performance analysis on board?
Right.
So at the moment, uh, we all know there's little doubt about the remarkable capabilities of artificial intelligence. We are experiencing it uh, personally in our everyday lives, and what with LLMs and virtual assistants and stuff like that. It's everywhere. So uh, that's okay. Using AI just for the hype because it's capable is not the answer. The question that we should be asking is, can we use AI for the problems that we are trying to solve, or should we use AI? I
Yeah.
think the question that we need to be asking is, should we use AI instead
Yeah.
of can we use AI? Of course, you can use AI, but are you going to get the results? The result, the problem statement should be clear in our mind, and only then we should go for whether AI is going to be useful for employment or not, or deployment or not. So, to answer your question, why AI? What can AI do?
Yeah.
So I'll give you briefly just 4 5 points. I can't elaborate too much on it. Firstly, it detects anomalies in real time, which is the cornerstone of condition monitoring.
Yeah.
And secondly, it predicts future equipment behavior. That is for maintenance instead of breakdown maintenance, planned maintenance. If AI can predict the future equipment behavior that is
Right.
remaining useful life, then you can go in for condition-based maintenance or predictive maintenance. Most important is it correlates data from multiple sources. So there is an integration of data because data on board is quite fragmented. It comes in silos. So correlating of data from multiple sources is a huge thing, and that is what AI is very good at, and it can give a lot of meaningful outputs from there. And of course, vast amount of data into actionable insights is one of the things which AI can do. So that is one. These are the reasons why we should be using AI, and these are very very pertinent, very relevant to uh, what we do on board. It can be really helpful. And then we come to the question, why now? What
Right.
has changed?
Yeah.
Today, there is both a business need for AI and the technology capable is waiting to be leveraged. So what has changed right now? Shipping industry right now operates under tight financial margins,
Right.
and the ESG and the decarbonization is increasingly getting stringent. So we need something more. We need something away from what we've been doing to
Right.
best uh, 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 increase our efficiency in
Yeah.
all aspects. So right now, technical, especially the technical part of it, the technical superintendents, the technical management is trying to control every controllable cost because technical management traditionally has not been a profit center. So they've got to do contribute their bit in
Right.
controlling the operating expenditure, and operating expenditure can only be controlled by how you manage your machinery. Managing machinery has become a big, it's almost amounts to 20 to 30% of your OPEX cost. So,
Okay.
and managing machinery, uh, like I said, predictive maintenance is the way to go about it. And right now, everything has come together with high frequency sensor data, reliable onboard connectivity, data storage, cloud computing, of course, our advances in artificial intelligence and machine learning. Now, there can't be a better time. Time is just right to leverage this and get run a ship or run an maritime organization as efficiently as you can.
Got it. So I think so. What I'm hearing is, it's a combination of, we have better data available. There's I mean, connectivity has improved, light years, and we've seen an advancement in advanced analytics, and all of this has fundamentally, well, it's changed what's possible. Yeah, and I think that naturally brings us to our next question, if you had to segue into it, and that is, if the data is the foundation, what does that foundation actually look like, right? And here's where I'd like to bring Pratul in. Pratul, a pleasure to have you. So Pratul, like you've spent decades sailing as a chief engineer across multiple vessels, of VLCCs and so. and now working closely with AI-enabled machinery monitoring. Um, you've seen both traditional and modern sides of maintenance. So before you answer that question, though, perhaps you could let our viewers know a little about your background and what drew you towards this, please. If you could, yeah, the floor is all yours.
Okay, thank you, Suraj. Good
Yeah,
afternoon, everybody. I am Major Pratul Joshi. I am
yeah.
a retired Army officer and also a Chief Marine Engineer who currently serves as a lead vessel performance analyst at Smartship Hub, which is a digital solution provider to the maritime industry, specializing in vessel performance and machinery condition monitoring through proper data analysis and AI-driven technologies. Now, looking at my career as such, I have served as a short service commissioned officer in the Indian Army before transitioning to the Merchant Navy as a junior marine engineer, and then self rose to the rank of chief engineer within 8 years. And over a seagoing career spanning nearly 3 decades, I've spent close to 20 years sailing as chief engineer about a variety of vessels, that is bulk carriers, VLCC tankers, gas tankers, and product tankers. Now, after retiring from active sailing about 3 years ago, I had briefly served as a visiting faculty at a maritime university before joining Smartship. Now, this marked a significant change in my career from a nation guardian as an officer in the Indian Army to also being responsible to the machinery of a single vessel to analyze data across entire fleets, applying analytics and machine learning to monitor machinery health, vessel performance, and operational efficiency. Now, while in Smart Ship, I have been working closely with ship owners, technical managers, and crews, and that has given me a valuable insight into the digital transformation now reshaping the maritime industry. Artificial intelligence is fast emerging as one of the key technologies which is driving the change. And today, Self will share some of these insights with all of us.
Thank you, Prathul. It's a pleasure to have you here, and thank you for your service as well.
Thank
So,
you so much.
moving on to our next question, we're talking about data foundations. So, my next question for you is, in today's day, if an organization wants to begin their journey towards AI-driven maintenance, what data needs to exist first? Like what are the important data sources, perhaps, is what I'm trying to get at.
Okay, to come to it, let us first think what is our raw data.
Yeah,
Raw data is basically has got a little value what we get from the ship unless and until this data is systematically acquired, validated, it is cleansed, it is analyzed, and converted into actionable insights that improve safety, reliability, and efficiency. And this is exactly what we do here. Smartship Hub works on acquired data standardization, that is ISO 19847 and 19848. So basically, it is all data engineering. What we do here, and using our domain experience, we are being able to type the data which we get. We have been able to classify them.
right,
There are various types of data. You see, you have machinery sensor data which is coming from AMS or a specific sensor of a machinery. You have operational data. Now, the data as such will change when the vessel is maneuvering, the vessel is out at sea, and when the vessel is at port. So, without an operational context, AI may think something is wrong when in reality the vessel is simply operating differently. So sitting here, we come to know exactly what exactly is the operational condition of the vessel. Now, to
sure,
add to it, we have environmental data. Now, ships don't operate in laboratories. You see, they are prone to change in weather, navigation data, your wind, speed, current. So, all are these data which are important for us. So
right,
now there is also an insight which we get from the performance reports or the historical work which has been done on the machineries. So all these, along with the human observations or a comment from a chief engineer or a crew, say if they have heard a loud sound or something, or this is having a rickety sound. So this
Yeah.
is all adding as an input to us. So data is, as I told you, is having various modes: machinery mode, operational mode, environmental maintenance, human observations. So these are all the things which we acquire out of here. Basically, again, you can divide the data into known data and HF data. When I'm saying known data, basically there are two frequencies on which we are operating. One is the low frequency, which is known as the known data, and
Yeah.
one which is known as high frequency data, which is your data which we are acquiring through cloud. So now I would like to rank them more. Number one as HF data. Now
Yeah.
you would ask me why. Now the question is, when we are going to use this modern technology of AI, we require more data points. So when we are seeing the HF data, say for an interval after every 15 minutes or 5 minutes or 10 minutes, so we are getting basically more data points for a day. So our analysis is very focused. And vis-a-vis in a known report, there is only one data point for reference as an average for last 24 hours. So
Yeah.
this makes the difference. You see, the HF data gives you the operational context, the fuel consumption, how it is varied, how the things parameters have behaved in the last 24 hours. So now this helps us to see how the machinery is behaving under various loads, how the sensors and transmitters, the control systems, the equipment logs, these how they are. We are acquiring everything out over here from these sensors and transmitters and the control systems or the alarm monitoring system. So we have been able to very deeply scrutinize. So that helps us in our analysis. So if you go to see the data undergoes through an acquisition process. You see, we do not acquire it straight away like that. We have a data generation at source. There's a data collection which comes through communication protocols. So there is a time synchronization of all data points, because if we have to match even the known report and the HF data, there has to be a synchronization. There is a data transmission is entirely coming to a central database where it is secured. All provisions are made for cyber security so that this data of a company or a vessel should not get leaked, and there is a backup. So this data is always available for us for analytics and visualizations. And now there are certain key considerations, like sampling frequency. Depending on what the client is demanding, they want data in 10 minutes or 5 minutes or 15 minutes. The data latency, the data integration, the data availability. There may be certain data which is not available to me. Maybe that particular type of ship is not having that particular type of data which can give me a deep insight. So all these things are very important for me as regards data is concerned. Now, once this data comes into us, to us, we have a validation check. We have a completeness check firstly, that is which will verify all the required parameters are available. We will identify which are the missing records, which we will calculate data availability percentage. We will see what is the range validation, whether the acquired parameter which has come, is it accepting within the normal operating limits, and we will flag that data which is incorrect. So you see, basically, it is all data engineering ultimately, which is being done here at HF in HF data acquisition.
Right.
We will see how the sensor is behaving. Perhaps there may be some frozen values, there may be some drifting sensors. So it is only through HF we will be able to identify how the trend set is. There will be a time series consistency check, which will ensure that the timestamps are sequential, which will detect communication interruption. And it will also, in case if there was a connectivity loss, we can detect there is a duplication of records. So all these things are very important in order to get insights into the data.
Okay. Got it. Got it. Thank you for that, Pratul. So, I mean, I think the takeaway is, data often gets discussed as a technical topic, but ultimately people need to trust the outputs generated from the data, right? And I think that's
Correct.
where, and that's where I think this conversation becomes particularly interesting, and it seems to be like a topic concerning most people, which simply put trust and transparency, right? So, I mean, if an AI system indicates that a critical component has limited useful life remaining, how should engineers start to think about that or think about that recommendation? I guess what I'm trying to say is, should AI be viewed as advisory or as authoritative? And Yash, you think you could take this question for us, please?
Yeah, sure. Uh, uh, AI, any advice from AI is not absolute. You have to recheck it. I mean, the best example of AI that we have right now, LLMs, uh, even that there's a caveat over there. This is generated by AI. It makes mistakes. So AI is reading the data and it doesn't. It's not contextual. So it reads the data, whatever the data tells you. If the data is wrong, if it's getting the wrong data, or if it's not getting the right data, it obviously is going to make mistakes. So, but let's talk about trust and transparency, because this is something which we keep getting questioned about whenever we go to our clients. They talk about how do we trust AI? Where is the transparency? So we'll take it one by one. Trust is built over time. That's a traditional wisdom, right? And uh, if you'll never get trust automatically. You tell them that, okay, this is the technology, this is how it works, and they'll have to try it, and it will have to be earned. Every major technological advancement in shipping, from GPS to ECDIS, they had to prove themselves through the years of reliable performance before gaining confidence of mariners. AI will have to follow the same path. Its initial days, it's been a year or two, where people have actually started deploying AI, and they are seeing the trust factor is building. They are seeing that, okay, it can be relied upon, not completely. It cannot be authoritative, like what you asked, but as an advisory, and the advices are quite okay. Quite advices quite reasonable, reliable, trustworthy. So, but how are the people, the client that we are working with? We help them in the process of building trust. We test it. We give them the algorithms. We give them the AI tools. We test it. We verify it, whether the algorithms are working okay, whether the answers are right, whether the output is okay. And then the reiteration comes. We reiterate over and over again till we get to a point where it gives a reasonably accurate answers or outputs.
Right.
These are, yeah, I'm sorry. Yeah, something you wanted to say?
No, no, no. Please go ahead. Please go ahead. I think what I was trying to get at is, you know, the humans, does human expertise predominantly, does it still continue to play a major role here?
That is the overlay. You cannot dispense that as much
Okay.
as AI, at least not in the marine environment, not in a ship environment, I would rather say. I
Okay.
am not very sure about the office and technical superintendents and all, but on board, even if you have an AI which tells you, advises you that you've got to change this particular part, or you got to change this particular machinery, or you overhaul a particular machinery, you'll have to think twice about it. You'll have to reason it out yourself through logic, because AI has got its own logic. Like I said, it doesn't have a context. We, as chief engineers over there, I mean, we have a context. We have experience over the years, and the intuitive value that we provide
Right.
will should support whatever AI says, or not support, as the case may be.
All right. So I
So
think that's an
yeah,
important distinction then, right? Because I think the goal isn't it's not replacing engineering judgment by any shape or means. In fact, it's strengthening it. Would you not agree with that?
absolutely, it's strengthening it. And if I had to think about me as a chief engineer on board with AI to assist me, I mean, I would be very, very happy. AI, the analogy which I heard some time back from one of the thought leaders of the industry. He said that AI should be like a second engineer, assistant to chief engineer, who
Hmm.
remembers every data, total historical data of all the machineries,
Hmm.
and it can correlate things between different machineries, between different components, and historically, and not only for that ship, it will know all the data for all the other ships. That's what we are doing. We are on the path of agentic AI, where we are giving them data which is like from the manuals to the plant maintenance system to the noon reports to experiences of not one ship, of all the ships, of all the sister ships. So it learns and it gives you valuable inputs, valuable insights. And as a chief engineer, I would be very happy if AI could really assist me in those ways.
Got it. I think so. I mean, if you look at, there is the chief engineer, and then you've got the primary, the tertiary, the auxiliary, right? So, but I
Yeah,
mean, even when the technology does exist, I suspect there is still a barrier of adoption, and I think that's something else I want to touch upon. What are the biggest barriers that are preventing organizations, and specifically in the maritime industry, from adopting AI? Is it technology? Is it culture? Processes? I mean, because we can compare it to other industries that are a lot more rapid with adopting AI. So, what seems to be what are some of the barriers that people tend to encounter? And Pratul, could you take this question up for us, please?
Yes, definitely, Suraj. First and foremost thing which I think is a biggest barrier is the mindset and the trust.
Right.
Now, to narrate a very simple thing, I'll tell you.
Yeah.
Previously, about 30 years back, the chief engineer, if he had a breakdown,
Right.
they will follow a particular way only and they will not deviate from that path because
Right.
the mindset was we have always done it this way, and any acceptance towards automated calls were not accepted. You see, this was done this way, this was experience, and this is how it will be attended to. So they were working on a fixed mindset. Now, why all these things took place? There was a this was the period or the era where these people had working till pre ISM days. Now, moment the ISM came in, the ISO standardization started, and then this is the time when people started going to the PMS part of it. Now, PMS again was predefined that it will go as per a definite periodicity of time. You will conduct a overall, or you will open up a machinery.
Right.
So there was a change in the pattern of how the maintenance would go about because ISM came in. Now, when this came with ISM, the preventive maintenance took form of a condition-based monitoring because there was a lot of repetitive work. There were a lot of things which were getting repeated, surveys were getting repeated, overall processes were getting repeated. So this then got changed to condition monitoring. As long as the condition was remaining good, the maintenance was according to that. But now with the technology advancement which is come in, uh, which perhaps few of them are still, because the old timers have now nearly gone. I mean, of my age and my experience, and new
Right.
people are they are a little bit susceptible to accepting this technology. But this technology is innovation which has come in a span of 4 5 years, and people have started relying on it. And this technology, once it is validated, we are now seeing AI in your maritime operations and industry. That is how it is getting inducted. So there is a barrier that mindset should allow and should be open to innovations. And this is an important barrier because people may not have that trust what earlier we were doing, that they were following a particular way to carry out a particular maintenance routine. So these are the barriers which will slowly go away. It is a passing phase. You see, nothing is constant in any industry. Uh, Things will change and people will adopt and they will feel comfortable. So that is how you see these are the barriers which will the data or anything will or the maintenance part of it will undergo. This is a phase, and they will overgrow this phase over a period of time.
Okay, understood.
As long as they are proving their value, they will be able to undergo this change, and this barrier which it is serving will break.
Okay, understood. So, but have you come across or have you seen any misconceptions that, you know, consistently slow down adoption? Because some people would say it's culture. Because we were just trying to understand what the barriers are, and if there are any misconceptions that people tend to look at. Are there any in the industry?
No, there are barriers in the sense barriers are there for your connectivity, legacy systems. You see, previously the connectivity was not there, so
Okay.
we were having only known reports. And then,
Yeah.
as and when the sat nav came, the connectivity issues got sorted out. The legacy system changed, the bandwidth limits were changed, and the older machineries without sensors, we could not get any data. But now, with this new technology, new sensors, new transmitters, we are getting where these sensor data is available to us. Also, the skills and the workload. The crews were earlier overstretched. Tools were, different. They were more of mechanical. So there were barriers in overcoming to adapt to the new change. So all these things are serving as barriers, and once these barriers are removed for data, they will be able to adapt to this new technology of AI into the maritime industry.
Got it. Thank you. Thank you. I think to encapsulate, I think adoption is often where good ideas succeed or fail. So, I think we've touched upon, why AI, why now, transparency, data foundations, barriers. Um, I think let's move in from theory into practice. Right? And I think this is the part that most people are interested in. So what does AI actually look like in action? So from what I gather, you've put together a real world scenario with regard to how AI helps identify, diagnose, and prevent issues. So do you think you could just take us through that, please?
Yes, I can definitely help you in this.
Sure.
May I share the screen for some time, please?
Yes, please. Absolutely.
Can you see my screen,
Yes, sir. The
Suraj?
floor is yours. Yes, please go ahead.
Okay, this is what is one model which we have made based on the AI part of it. We receive the data online from our servers for a particular vessel and a dashboard. This is a dashboard which anyone can make, and nothing more this thing in over it. But then you see there are certain things which have been incorporated into this dashboard, which is the engine overview for a particular ship, where at a glance you can see all the parameters which are being received in the data. And in the same dashboard, we have put in the entire vessel's history as such. Basically, for an engineer, there is a shop trial data to look into, so that he doesn't have to refer to the any manuals or anything. So everything has been put in as what has been inputted from the shop trial data. Now, why this has been put? Because this will serve as a baseline. This will serve as a reference line for any anomaly to be detected. We require these baselines. We also have for the speed power curves for the ship right from the shop trial, the sea trial. At various drafts, we have got these curves which will be able to tell us at the operating point what is the propeller, what is the cubic relation. All these things can be directly seen on the screen for a particular ship. We have also taken into consideration the hydrostatic data as a reference line because the ship with the draft is going to change at all instances. So we can estimate roughly that at a glance with a flick of a button what will be the displacement. So these things are all readily available for a quick reference to that particular vessel. So basically, the model has been made in order to analyze the data which is coming in, and it has been subjected to the AI. So basically, we will be able to detect now, in the sense, because your noon report you have got only one data point as reference, whereas in your HF data you've got, say, 90, say if it is 15 minutes per data point, you've got 96 data points for one particular day, so you're more accurate. And this is what actually AI requires: a larger data set for that particular day so that it can detect anomaly. So now, why we would like to see the anomaly? Because anomaly detection identifies when the equipment behavior is deviating from its established normal operating signature. The system learns what healthy looks like across multiple correlated sensor parameters, that is temperatures, pressures, vibrations, loads, and it flags statistically the significant departure from that baseline. Now, we have got the, like, say we have a relation of SFOC, exhaust temperature, scavenge. We can see the deviation out over here, how the SFOC is changing over a period of time as per the calendar date, and we have a quick reference to this immediately, and we have got early warnings for all these deviations. So the AI will be able to give you an early deviation, and which will be able to set your thinking process for bringing normalcy. Now, coming to health index. Now, there is a health index which condenses many parameters into a single normalized score. That means it is from 0 to 100 and representing overall asset condition. That how the condition, it gives an operator at a glance status and a color coded layer. You know, that is green, amber, orange, red, for prioritizing across a fleet. You see, it will consider so many things: thermal, scavenging, speed hull, turbocharger, and overall these parameters, they will be able to give you the overall engine health, combustion health, the thermal health, and the turbocharger health. And as you see, if under a ideal condition or baseline, if the score was given 100, and over a period of time, over a time frame from the x-axis, you will see if the health index is deteriorating. And moment it comes to a predetermined level, we will get an advisory alarm alert that there is a warning threshold you are breaching, and there is something wrong with these parameters. So now this is a very important indicator of a KPI to a vessel operator, that what is the health index of this vessel. Now, coming to fault classification. Now, there will be so many faults which will generate over a period of time, but historically, to correlate it and classify them, we require something known as fault classification. Now, fault classification moves beyond something is wrong to what specifically it is wrong, identifying the fault type, that is whether it is the bearing or it is a combustion imbalance or whether it is a turbocharger. So this will get classified, and we will have a probability of the which component is likely to give you the, basically we'll be able to see the confidence level of these components which are leading to these faults. So it will give you the 100% confidence, or a plunger barrel, or a fouling reduced, or compressor turbine fouling, or a ring wear, and accordingly it will give you the alert if as and when required. Now, most important thing, as per the advantage, the highest advantage of HF data is monitoring the degradation trends. Now, this is entirely online, which we are seeing it. We will be seeing what is the SFOC degradation of the vessel, how much is the exhaust temperature trend per cylinder, how it is deviating from the average exhaust temperature. We can online study this. We can see how the Pmax has been deviating, how the speed loss has been taking, perhaps giving an indication also of a fouled hull, the turbocharger, and the scavenging degradation of the RPM and the temperatures. So all these parameters can be very easily monitored, and we will be able to see the degradation trends of the same. Now, coming to the RUL prediction. Now, RUL is basically the remaining useful life which estimates the time or the operating hours until an asset reaches a defined threshold, failure threshold. They are very well clearly defined that by so much time anticipated, it is likely to fail. So, how is it helping us? It is enabling the condition based and the predictive maintenance planning rather than fixed interval servicing. So we will come to know in advance that when is a instrument likely or a component likely to fail. Now this is possible only in HF data, and we as a Smart Ship Hub are experts in data management and data engineering, and this comes into a big help to us to forewarn the person or the company that this component is likely to fail. Where you see the RUL that this is the threshold it has already crossed of 75%, and at this point it is likely to fail. So we can foresee it either 7 days, 30 days or 60 days in advance. So we will get a RUL confidence bar for all components which we have earmarked for piston rings or turbocharger, fouling, nozzle ring, fuel pumps. We also get a cylinder level injector health index, which will tell us that most probably the health index of this number three, perhaps the maintenance has not been carried out for a long time, and the combustion parameters are indicating that the health index of this is in relation to other parameters is going every. So it will tell us that number three and number five cylinders are not proper in comparison with other units, and perhaps it will give you a pre-warning alarm. Again, if it is short for a critical thing, it will show in red. If it has got a long period of time, perhaps it will show in amber. And if it is the confidence level is higher, then perhaps it may go up to more than 90 days and all. That is what we can set up to. So this is how you see how data is helping us, and data is totally dependent again on high frequency data rather than the data engineering. I'll say it is more specific, and this is where we specialize it, and we are using this AI technology to the maximum.
So thank you for that, Pratul. I think when you break it down like that and take us through a walkthrough, I think we're able to understand the kind of value and the kind of how AI is able to take data and help you all essentially convert raw data into data visualization and help you all make decisions that are a lot more accurate with quicker turnaround time. So I think thank you for that. I think we're approaching the end of our session here, so I think we'll just open the floor out to our viewers if they've got any questions. If they do, we could field a few of them. So I mean, just give it a minute or two. If anyone has any questions, they could drop them in the comments, and we could try and answer them to the best of our ability. All right, I think we have a question from Malvika, and I think it's on our screen. So can older vessels benefit from AI-based condition monitoring, or is this mainly for newer fleets? Pratul, I think this question is for you.
Yeah, Malvika, very good question. That can older vessels benefit from this? Yes, of course. Why not? As long as the older vessels are there, the required data can be acquired by. We have a setup box where we can acquire the data, and a smart ship as such has got the cheapest offer in the world today to acquire the data and give it across to our servers, and we will be able to analyze it. But yes, newer vessels will have more because the newer vessels have got a better technology and better alarm monitoring systems. They will have more data points, more sensors, so the number of data points will be higher. But yes, older vessels can benefit also from AI based condition monitoring. So there is no embargo that older vessels cannot.
All right, thank you for that. I think we've got another question. This one's from uh, Payal. I think Yash, would you like to take this question? What are the first signs that an AI deployment is actually delivering value?
As a company, we keep getting asked, when are we going to see the value coming back? So what we, as a company, as a solution provider, the first question is, what have you set out for? What have you set out to achieve? And according to that, we measure. Sometimes you cannot, it is intangible, you cannot actually measure it, you cannot give a dollar value to it. So but most of the companies, they would like to know what is the ROI is like, and they are not wrong over there. If they are going to be investing in something like AI, which hasn't yet proven its value, then they're definitely going to ask, when I see value. And so the first indication, let's see, practically, if there is a reduction in unplanned breaks, the breakdowns go down. That means your maintenance is good. That means your predictive maintenance is good. That means uh, reliability of machinery is good. So that is a tangible one. But very interesting. I don't know whether I have time for this, but we had just gone to Singapore, and a couple of days. Just when we were in Singapore, and we had a client visit, and there was this Dali incident which crashed into the Baltimore Bridge. I don't remember the name of the bridge. And then we were with the technical department of that company, and they said that, okay, let's see, as a thought experiment, could AI have averted this incident, which cost, I don't know, 100 million or something like that. I don't have any idea. So we, as like solution provider, of course we could, I mean, and we had a data people, we had developers and all that. So they said, yeah, yeah, of course we can. And we gave them a plan, which I'm not saying that was like authentic, and it could have actually, but as a thought thing, and they kind of liked it. And so, what accidents it can avert, what it can do, is not measurable right now. It cannot be measured day to day. After it happens to measure it, it's a different thing. But those, uh, uh, as time passes by, as more ships adopt AI for their condition monitoring, I think we'll see a lot more instances where solutions are provided, money is saved. And but the first sign, I would say, coming back to your question, is unplanned breakdowns reduction, equipment reliability, better maintenance planning, and of course fuel and energy efficiency, and all those kind of things, they all go hand in hand. They're reduced false alarms. These are the things which actually say that AI is working for you. These are the first signs.
All right. Thank you so much for that. I think we have time for one more question. This one is from Shiv, and it is, what do you what do you think will have the biggest impact on machinery maintenance over the next 5 years? Pratul or Yash, which one of y'all want to field this question? I mean, y'all can decide.
I would just like to add one thing which Yash said. There's
Sure.
a saying that for want of a nail, a kingdom was lost. So perhaps a
Okay.
bearing which would have costed $2,000
Right.
or something like that, and had the predictive maintenance would have been in place,
Right.
we would have got a pre-warning to this failure much earlier. So you
Okay.
see, that's exactly what Yash is saying. The downtime gets reduced drastically, and after a breakdown, if you are incurring a cost because of your downtime, find that particular spare at the last minute, it is going to have a lot of cost impact onto the management company or to the owner.
Right.
So basically, through using AI and through HF data, we can cut down these things to a large level, and they perhaps operating cost and the fuel saving cost and all. You can save good about 20% to 30% your operating costs as such.
Wow. So constant supervision enforces prevention is
Correct.
better than cure. I suspect that is what we're trying to achieve here. So yeah, I
So,
think this is one
Shiv
last
had
question.
asked, what do you think will have the biggest impact on machinery maintenance? Well, machinery maintenance will go on. It has been going on in the past also, but the repetitive work, and there is something known as a surgical strike on the machinery, I'll say, only do it when required. That concept is coming in now. With AI, we will be able to reduce, in fact, our maintenance and carry out the maintenance only when required, because the technology is to our rescue. We will come to know when the equipment and when the component is degrading, and we will get a sufficient notice. We will see the trend patterns. There will be a documentary evidence. We will be able to visualize it, how the component is deteriorating in its health, in the parameters, in the trend curves, and we can attack it just before safely before the component is likely to fail, which otherwise in PMS we were doing it at a periodic interval and perhaps at a higher cost, incurring higher cost in spares. So we will be doing maintenance just before the required time when it is likely to fail. So this is the impact it is going to have on the machinery maintenance in the next 5 years.
Understood. Thank you for that. I think we're just about the end of our session. So, I mean, I'm sorry we couldn't field all questions, but I'd like to thank Pratul and Yash for sharing their perspectives and
Thank you.
experiences. Today's discussion, if anything, highlighted something important, that AI is not here to replace engineers such as yourselves. If anything, it gives you all better visibility, better context, and better decision support, you could say, because the future of machinery maintenance won't be defined by simply technology alone, but
Yeah.
by how effectively organizations combine that operational expertise with human intelligence and data-driven intelligence.
Yeah.
So thank you to everyone who joined us today. If you'd like to continue the conversation or learn about SmartShip Hub's approach to machinery condition and predictive maintenance, please feel free to connect with engineers such as Yash and Pratul. They will be more than happy to
Sure.
help out. I think do you think we have time for one last question? By Venkat, we could feel this. Venkat, we will get back to you on that question. We're just so short on time. But I'm so sorry we couldn't feel that. But thank you everyone for joining. And yeah, thank you, Pratul and Yash. And have a great, great day.
Thank you,
Thank
Suraj.
Thank
Thank
you.
you, Suraj. It was nice having a
Thank you.
debate with you. Thank you so much. Have a nice day.
you.
See you.
Thank you. Yeah.
Bye.
Bye.